This video is about special right triangles and specifically 45, 45, 90 triangles. So if you know anything about 30, 60, 90 triangles, you are going to think 45, 45, 90 triangles are much nicer. And that's because a 45, 45, 90 triangle is an isosceles triangle, meaning that two sides are congruent. So the two legs, the two sides that make up that right angle, are going to be congruent to each other. And that is just our base side. Just like in a 30, 60, 90, we have the short leg being the base side. S and S, both legs are our foundation. The most important part of every right triangle is that hypotenuse. That's the side opposite that right angle. And in a 45, 45, 90 triangle, you just take whatever the side length is, the leg length is, and you multiply that by the square root of 2. So again, if you know this relationship, you're able to find the lengths of the sides of the triangles if you only have one or maybe two sides and Pythagorean theorem is not an option. Let's look at some examples. Here's a 45, 45, 90 triangle. So again, always label your sides. Find your two legs, find your hypotenuse. And remember, in a 45, 45, 90 triangle, it's isosceles, so our two legs are going to be congruent to each other. So in this case, if one leg is 30, that means the other leg is also 30. So M is equal to 30. Easy as that. In this example, we're not given either of the two legs, so we're going to label our sides. And it asks us to find two variables, M and P, but remember, those are actually going to be the same length here. Both of those legs are going to be congruent. So as soon as we find one of them, we know M and P are going to be equal to each other. So our hypotenuse here is 10 times the square root of 2. And remember, our sides are S, S, and that S times the square root of 2. So again, if our hypotenuse is 10 times the square root of 2, and we solve this little equation, if I divide both sides by the square root of 2, we get S to be 10. So both M and P in this equation, both of our two legs, are the same length, and they both equal 10. That number in front of the square root. In this last example, again, labeling our side lengths, we know the hypotenuse is that side that is the square root of 6. So the same thing that we just did in that last problem, we are going to know that this side is S times the square root of 2. Our hypotenuse is whatever our leg is times the square root of 2. So we're going to solve this equation. I'm going to pull it over here just so it's easier to see. So S times the square root of 2 is equal to that hypotenuse, the square root of 6. So just like in that last example, I'm going to get rid of this square root of 2 in order to isolate my variable S to figure out what it equals. And in this case, I can write this all as one big square root. I can do this as the square root of 6 divided by 2, and we know 6 divided by 2 is 3. So in this case, our leg, M, is equal to the square root of 3.